Now we will know about the relative measure, which is related to variance and standard deviation, which is the coefficient of variance. The coefficient of variation is defined as the ratio of the standard deviation to the mean, that is the population CV is dividing sigma by mu. Here you can see this is the population standard deviation and this is the population mean, and the value is multiplied by 100 to get in percentage, and the sample CV, that is coefficient of variation, is dividing the sample standard deviation by sample mean and multiply it by 100 to get in percentage. And you can see we are dividing the standard deviation, though we are telling it the coefficient of variation. So you have to just remember this, that we are dividing the value standard deviation, not the variance. So what does it do? The coefficient of variation shows the extent of variability in relation to the mean of the population. The coefficient of variation should be computed only for data measured on a ratio scale. That is, for ratio we should measure the coefficient of variation. For comparison between datasets with different units or widely different means, one should use the coefficient of variation instead of the standard deviation. That is, if we use the standard deviation, then the widely spread, that is widely different, means that there, suppose one has mean 8 and another has mean 1000, but so the comparison of standard deviation would not be good. For this reason we need CV to compare this type of datasets. Coefficient of variation is free of unit, that is unitless, and the standard deviation is divided by the corresponding arithmetic mean to make it comparable for different means. To compare the variability of two sets of data, that is to determine which set is more variable, we need to calculate the arithmetic mean and standard deviation of both sets. We can calculate then the coefficient of variations for both sets. The dataset with larger value of coefficient of variation has larger variation, which is expressed in percentage. For example, the relative variability of the dataset 1 will be larger than dataset 2 if CV1 is greater than CV2 and vice versa. So let us see an example. In a university, students can take any number of courses per semester. For two samples of 30 students each, the data of how many courses one takes is given below. That is, the course number 2 is taken by 2 persons from sample 1 and 1 student from sample 2, and course number 4 is taken by 10 students of sample 1 and 8 students of sample 2, and so on. 2, 3, 4, 5, 6, there are 5 courses. For which sample of students the relative variability of course number is higher? So we have to calculate the arithmetic mean, that is we have to sum the frequencies, that is the sum the number of students, and after that we have to find out the arithmetic mean, and then we have to find out the variance. You already know how to find out them, and remember this is sample, so you should use the sample variance, and after that the standard deviation, just take the square roots and then compare the coefficient of variation, that is you take the ratio of SD and AM and express it in percentage. Now we will know about combined standard deviation. The combined standard deviation of two sets of data containing n1 and n2 observations, that is the number of observations are different, with means mu1 and mu2, that is the means are also different and standard deviations are also different, the data sets are different. and the combined standard deviation is given by this formula, that is sigma 1 2 is equal to n1 into sigma 1 square plus d1 square. Oh, we have got a new term d1 and d2 here. So what are these? d1 is the difference of mu 1 2 and mu 1. So what is mu 1 2? Mu 1 2 is again the combined mean, that is n1 mu 1 plus n2 mu 2 divided by n1 plus n2. It is also the weighted average you have known in the measure of central tendency. So you just find the difference and find the value of sigma 1 2 using this formula. So this formula of combined standard deviation of two sets of data can be extended to compute the standard deviation of more than two sets of data on the same lines. That is, we can just take n3 and sigma 3 and d3 and just write here sigma 1 2 3. You can see there are some data, that is from the analysis of monthly wages paid to employees in two service organizations X and Y. The following results are obtained, that is the number of wage earners in organization X and in organization Y. You can see this is population because the monthly wages of employees in service organization, that is all the employees are counted. So here you can see the population size is 550. So we get this is n1 and this is n2, and you can see the average monthly wage. So this is mu 1 and this is mu 2, and after that the variance, you can see here the variance is given. So we can say that this is sigma 1 square and this is sigma 2 square. So you now know the value of n1, n2, sigma 1, sigma 2 and the value of mu, and from mu you can calculate d also. So you just apply this formula and from this data set and get the combined variance, that is which organization pays a larger amount as monthly wages. You can just say that from the average and determine the combined variance of all the employees. And you can see the this problem is actually easy. I have pointed out n1 mu 1 and sigma 1 and n2 mu 2 and sigma 2. Now there is another test. For a group of 50 male workers, the mean and standard deviation of their monthly wages are 6,300 and taka 600 respectively. For a group of 40 female workers, these are taka 5,400 and taka 600 respectively. Now what is the standard deviation of monthly wages for combined group? Here also you can see this is our n1, this is our the mu, that is not the mu, this is the mu, and you can the average, yes, and this is the standard deviation. So this is actually sigma 1, and here also it is n2, and this is our mu 2, and finally this is our sigma 2. Here you can see the standard deviation is given, not the variance, and in this previous problem the variance was given. So you have to think this carefully, that what is where the variance is given or the standard deviation is given in the problem. Let us see some application of standard deviation. In stock charts, the standard deviation is a measure of volatility. The chartists can use standard deviation to measure expected risk and determine the significance of certain price movements. Bollinger Bands show the upper and lower limits of normal price movements based on standard deviation of prices. It is also used in financial analysis. In many fields of science and business studies, standard deviation is significant. From the variance and standard deviation, we can understand the fitness of a statistical model when we deal with the dependencies of data. There are some merits and demerits of variance as a dispersion measure. It is rigidly defined, first is the merits, and also it is based upon all observation. It is easy to understand. It is less affected by sampling fluctuations, and it is suitable for further algebraic treatment. What are the demerits? It is difficult to calculate, that is, finding the square is very difficult, and also it is affected by extreme values, because when extreme value is present, the square of difference is also extreme, and it is difficult to calculate for open-end class.